Mars is the fourth planet from the Sun. The planet is one of Earth's next-door neighbors in space. Earth is the third planet from the Sun, and Jupiter is the fifth. Like Earth, Jupiter, the Sun, and the remainder of the solar system, Mars is about 4.6 billion years old. Mars is named for the ancient Roman god of war. The Romans copied the Greeks in naming the planet for a war god. The Greeks called the planet Aries. The Romans and Greeks associated the planet with war due to its blood-like color. Viewed from Earth, Mars is a bright reddish-orange. It owes its color to iron-rich minerals in its soil. This color is also similar to the color of rust, which is composed of iron and oxygen. Scientists have observed Mars through telescopes based on Earth and in space. Space probes have carried telescopes and other instruments to Mars. Early probes were designed to observe the planet as they flew past it. Later, spacecraft orbited Mars and even landed there. But no human being has ever set foot on Mars. Scientists have found strong evidence that water once flowed on the surface of Mars. The evidence includes channels, valleys, and gullies on the planet's surface. If this interpretation of the evidence is correct, water may still lie in cracks and pores in subsurface rock. In addition, a group of researchers has claimed to have found evidence that living things once dwelled on Mars. That evidence consists of certain materials in meteorites found on Earth. But the group's interpretation of the evidence has not convinced most scientists. The Martian surface has many spectacular features, including a canyon system that is much deeper and much longer than the Grand Canyon in the United States. Mars also has mountains that are much higher than Mount Everest, Earth's highest peak. Above the surface of Mars lies an atmosphere that is about 100 times less dense than the atmosphere of Earth. But the Martian atmosphere is dense enough to support a weather system that includes clouds and winds. Tremendous dust storms sometimes rage over the entire planet. Mars is much colder than Earth. Temperatures at the Martian surface vary from as low as about -125 degrees Celsius near the poles during the winter to as much as 20 degrees Celsius at midday near the equator. The average temperature on Mars is about -60 degrees Celsius. Mars is so different from Earth mostly because Mars is much farther from the Sun and much smaller than Earth. The average distance from Mars to the Sun is about 227,920,000 kilometers. This distance is roughly 1.5 times the distance from Earth to the Sun. The average radius of Mars is 3,390 kilometers, about half the radius of Earth. Characteristics of Mars: orbit and rotation. Like the other planets in the solar system, Mars travels around the Sun in an elliptical orbit. But the orbit of Mars is slightly more stretched out than the orbits of Earth and most of the other planets. The distance from Mars to the Sun can be as little as about 206,620,000 kilometers or as much as about 249,230,000 kilometers. Mars travels around the Sun once every 687 Earth days. This is the length of the Martian year. The distance between Earth and Mars depends on the positions of the two planets in their orbits. It can be as small as about 54,500,000 kilometers, or as large as about 401,300,000 kilometers. Like Earth, Mars rotates on its axis from west to east. The Martian solar day is 24 hours, 39 minutes 35 seconds long. This is the length of time that Mars takes to turn around once with respect to the Sun. The Earth day of 24 hours is also a solar day. The axis of Mars is not perpendicular to the planet's orbital plane, an imaginary plane that includes all points in the orbit. Rather, the axis is tilted from the perpendicular position. The angle of the tilt, called the planet's obliquity, is 25.19 degrees for Mars, compared with 23.45 degrees for Earth. The obliquity of Mars, like that of Earth, causes the amount of sunlight falling on certain parts of the planet to vary widely during the year. As a result, Mars, like Earth, has seasons, mass and density. Mars has a mass of 642 followed by 20 tons. Earth is about 10 times as massive as Mars. Mars's density is about 3.933 grams per cubic centimeter. This is roughly 70% of the density of Earth. Gravitational force. Because Mars is so much smaller and less dense than Earth, the force due to gravity at the Martian surface is only about 38% of that on Earth. Thus, a person standing on Mars would feel as if his or her weight had decreased by 62%. And if that person dropped a rock, the rock would fall to the surface more slowly than the same rock would fall to Earth. Physical features of Mars. Interior. Scientists do not yet know much about the interior of Mars. A good method of study would be to place a network of motion sensors, called seismometers, on the planet's surface. Those instruments would measure tiny movements of the surface, and scientists would use the measurements to learn what lies beneath. Researchers commonly use this technique to study Earth's interior. Scientists have four main sources of information on the interior of Mars. 1. Calculations involving the planet's mass, density, gravity, and rotational properties. 2. Knowledge of other planets. 3. Analysis of Martian meteorites that fall to Earth. And 4. Data gathered by orbiting space probes. They think that Mars probably has three main layers, as Earth has: a crust of rock, a mantle of denser rock beneath the crust, and a core made mostly of iron. Crust. Scientists suspect that the average thickness of the Martian crust is about 50 kilometers. Most of the northern hemisphere lies at a lower elevation than the southern hemisphere. Thus, the crust may be thinner in the north than in the south. Much of the crust is probably composed of a volcanic rock called basalt. Basalt is also common in the crusts of Earth and the Moon. Some Martian crustal rocks, particularly in the northern hemisphere, may be a form of andesite. Andesite is also a volcanic rock found on Earth, but it has more silica than basalt does. Silica is a compound of silicon and oxygen. Mantle. The mantle of Mars is probably similar in composition to Earth's mantle. Most of Earth's mantle rock is peridotite, which is made up chiefly of silicon, oxygen, iron, and magnesium. The most abundant mineral in peridotite is olivine. Due to radioactive heating, the average temperature of the Martian mantle may be roughly 1,500 degrees Celsius. Core. Mars probably has a core composed of iron, nickel, and sulfur. The density of Mars gives some indication of the size of the core. Mars is much less dense than Earth. Therefore, the radius of Mars's core relative to the overall radius of Mars must be smaller than the radius of Earth's core relative to the overall radius of Earth. The radius of the Martian core is probably between 1,500 and 2,000 kilometers. Unlike Earth's core, which is partially melted, the core of Mars probably is solid. Scientists suspect that the core is solid because Mars does not have a significant magnetic field. A magnetic field is an influence that a magnetic object creates in the region around it. If a planet's core is molten, motion within the core due to the planet's rotation makes the core a magnetic object. Data from the Mars Global Surveyor space probe show that some of the planet's oldest rocks formed in the presence of a strong magnetic field. Thus, in the distant past, Mars may have had a hotter interior and a molten core. Surface features. Mars has many of the kinds of surface features that are common on Earth. These include plains, canyons, volcanoes, valleys, gullies, and polar ice. But craters occur throughout the surface of Mars, while they are rare on Earth. In addition, fine-grained reddish dust covers almost all the Martian surface. Plains. Many regions of Mars consist of flat, low-lying plains. Most of these areas are in the northern hemisphere. The lowest of the northern regions are among the flattest, smoothest places in the solar system. They may be so smooth because they were built up from deposits of sediment. There is ample evidence that water once flowed across the Martian surface. The water would have tended to collect in the lowest spots on the planet and thus would have deposited sediments there. Canyons. Along the equator lies one of the most striking features on the planet, a system of canyons known as the Valles Marineris. The name is Latin for Valleys of Mariner. A space probe called Mariner 9 discovered the canyons in 1971. The canyons run roughly east-west for about 4,000 kilometers, which is close to the width of Australia or the distance from Philadelphia to San Diego. Scientists believe that the Valles Marineris formed mostly by rifting, a splitting of the crust due to being stretched. Individual canyons of the Valles Marineris are as much as 100 kilometers wide. The canyons merge in the central part of the system, in a region that is as much as 600 kilometers wide. The depth of the canyons is enormous, reaching 8 to 10 kilometers in some places. Volcanoes. Mars has the largest volcanoes in the solar system. The tallest one, Olympus Mons, Latin for Mount Olympus, rises 27 kilometers above the surrounding plains. It is about 600 kilometers in diameter. Three other large volcanoes, called Arsia Mons, Ascrius Mons, and Pavones Mons, sit atop a broad uplifted region called the Tharsis Montes. All these volcanoes have slopes that rise gradually, much like the slopes of Hawaiian volcanoes. Both the Martian and Hawaiian volcanoes are shield volcanoes. They formed from eruptions of lavas that can flow for long distances before solidifying. Craters and impact basins. Many meteoroids have struck Mars over its history, producing impact craters. Impact craters are rare on Earth for two reasons. 1. Those that formed early in the planet's history have eroded away, and 2. Earth developed a dense atmosphere, preventing meteorites that could have formed craters from reaching the planet's surface. Martian craters are similar to craters on Earth's moon, the planet Mercury, and other objects in the solar systems. The craters have deep, bowl-shaped floors and raised rims. Large craters can also have central peaks that form when the crater floor rebounds upward after an impact. Mars has a few large impact craters. The largest is Hellas Planitia in the southern hemisphere. Planitia is a Latin word that can mean low plain or basin. Hellas Planitia is also known as the Hellas Impact Basin. The crater has a diameter of about 2,300 kilometers. The crater floor is about 9 kilometers lower than the surrounding plain. Channels, valleys, and gullies occur in many regions of Mars, apparently as a result of water erosion. The most striking of these features are known as outflow channels. These channels can be as wide as 100 kilometers and as long as 2,000 kilometers. They appear to have been carved by enormous floods that rushed across the surface. In many cases, the water seems to have escaped suddenly from underground. Many of the channels do not look like river systems on Earth, with the main river formed from smaller rivers and streams. Rather, those Martian channels arise fully formed from low-lying areas. Other regions of Mars have much smaller features, called valley networks. These networks look more like river systems on Earth. Martian valley networks are up to a few miles or kilometers wide and up to a few hundred miles or kilometers long. The networks are mostly ancient features. They suggest that the Martian climate may once have been warm enough for water to exist as a liquid. The gullies are smaller still. Most of them lie at high latitudes. They may be a result of a leakage of a small amount of groundwater to the surface within the past few million years. Polar deposits. The most interesting features in the polar regions of Mars are thick stacks of finely layered deposits of material. Scientists believe that the layers consist of mixtures of water, ice, and dust. The deposits extend from the poles to latitudes of about 80 degrees in both hemispheres. Atmosphere. The atmosphere of Mars contains much less oxygen than that of Earth. The content of the Martian atmosphere is only 0.13%, compared with 21% in Earth's atmosphere. Carbon dioxide makes up 95.3% of the gas in the atmosphere of Mars. Other gases include nitrogen, 2.7%, argon, 1.6%, carbon monoxide, 0.07%, and water vapor, 0.03%. Pressure. At the surface of Mars, the atmospheric pressure is typically only about 0.10 pound per square inch. This is roughly 0.7% of the atmospheric pressure at Earth's surface. When the seasons change on Mars, the atmospheric pressure at the surface there varies by 20 to 30%. Each winter, the condensation of CO2 at the poles removes much gas from the atmosphere. When this happens, the atmospheric pressure due to CO2 gas decreases sharply. The opposite process occurs each summer. In addition, the atmospheric pressure varies as the weather changes during the day, much as on Earth. Temperature. The atmosphere of Mars is coldest at high altitudes, from about 65 to 125 kilometers above the surface. At those altitudes, typical temperatures are below -130 degrees Celsius. The temperature increases toward the surface, where daytime temperatures of -30 to -40 degrees Celsius are typical. Atmospheric temperatures can be warmer than normal when the atmosphere contains much dust. The dust absorbs sunlight and then transfers much to the resulting heat to the atmospheric gases. Clouds. In the Martian atmosphere, thin clouds made up of particles of frozen CO2 can form at high altitudes. In addition, clouds, haze, and fog composed of particles of water ice are common. Haze and fog are especially frequent in the early morning. At that time, temperatures are the lowest and water vapor is therefore most likely to condense. Wind. The Martian atmosphere, like that of Earth, has a general circulation, a wind pattern that occurs over the entire planet. Scientists have studied the global wind patterns of Mars by observing the motions of clouds and changes in the appearance of wind-blown dust and sand on the surface. Surface winds on Mars are mostly gentle, with typical speeds of about 10 kilometers per hour. Scientists have observed wind gusts as high as 90 kilometers per hour. However, the gusts exert much less force than do equally fast winds on Earth. The winds of Mars have less force because of the lower density of the Martian atmosphere. Dust storms. Some of the most spectacular weather occurs on Mars when dust blows in the wind. Small, swirling winds can lift dust off the surface for brief intervals. These winds create dust devils, tiny storms that look like tornadoes. Large dust storms begin when wind lifts dust into the atmosphere. The dust then absorbs sunlight, warming the air around it. As the warmed air rises, more winds occur, lifting still more dust. As a result, the storm becomes stronger. Dust storms are most common when Mars is closest to the Sun. More storms occur then because that is when the Sun heats the atmosphere the most. Satellites. Mars has two tiny moons, Phobos and Deimos. The American astronomer Asaph Hall discovered them in 1877 and named them for the sons of Aries. Both satellites are irregularly shaped. The largest diameter of Phobos is about 27 kilometers, that of Deimos, about 15 kilometers. The two satellites have many craters that formed when meteoroids struck them. The surface of Phobos also has a complicated pattern of grooves. These may be cracks that developed when an impact created the satellite's largest crater. The color of both satellites is a dark gray that is similar to the color of some kinds of asteroids. Evolution of Mars. periods of evolution. Scientists know generally how Mars evolved after it formed about 4.6 billion years ago. Their knowledge comes from studies of craters and other surface features. Features that formed at various stages of the planet's evolution still exist on different parts of the surface. Researchers have developed an evolutionary scenario that accounts for the sizes, shapes, and locations of those features. Researchers have ranked the relative ages of surface regions according to the number of impact craters observed. The greater the number of craters in a region, the older the surface there. However, scientists have not yet determined exactly when the various evolutionary stages occurred. To do that, they would need to know the ages of rocks of surface features representing those stages. They could determine how old such rocks are if they could analyze samples of them in a laboratory. But no space probe has ever brought Martian rocks to Earth. Scientists have divided the lifetime of Mars into 3 periods. From the earliest to the most recent, the periods are 1. The Noachian, 2. The Hesperian, and 3. The Amazonian. Each period is named for a surface region that was created during that period. The Noachian period is named for Noches Terra, a vast highland in the southern hemisphere. During the Noachian period, a tremendous number of rocky objects of all sizes, ranging from small meteoroids to large asteroids, struck Mars. The impact of those objects created craters of all sizes. The Noachian was also a time of great volcanic activity. In addition, water erosion during the Noachian period probably carved the many small valley networks that mark Mars' surface. The presence of those valleys suggests that the climate may have been warmer during the Noachian period than it is today. The Hesperian period. The intense meteoroid and asteroid bombardment of the Noachian period gradually tapered off, marking the beginning of the Hesperian period. This period is named for Hesperia Planum, a high plain in the lower latitudes of the southern hemisphere. During the Hesperian period, volcanic activity continued. Volcanic eruptions covered over Noachian craters in many parts of Mars. Most of the largest outflow channels on the planet are of Hesperian age. The Amazonian period, which is characterized by a low rate of cratering, continues to this day. The period is named for Amazonas Planitia, a low plain that is in the lower latitudes of the northern hemisphere. Volcanic activity has occurred throughout the Amazonian period, and some of the largest volcanoes on Mars are of Amazonian age. The youngest geologic materials on Mars, including the ice deposits at the poles, are also Amazonian. Possibility of life. Mars might once have harbored life, and living things might exist there even today. Mars almost certainly has 3 ingredients that scientists believe are necessary for life. 1. Chemical elements, such as carbon, hydrogen, oxygen, and nitrogen, that form the building blocks of living things. 2. A source of energy that living organisms can use. And 3. Liquid water. The essential chemical elements likely were present throughout the planet's history. Sunlight could be the energy source, but a second source of energy could be the heat inside Mars. On Earth, internal heat supports life in the deep ocean and in cracks in the crust. Liquid water apparently carved Mars's large channels, its smaller valleys, and its young gullies. Thus, water apparently has existed near the surface over much of the planet's history. And water is probably present beneath the surface today, kept liquid by Mars's internal heat. History of Mars study. Observation from Earth. Observing Mars through Earth-based telescopes, early astronomers discovered polar caps that grow and shrink with the seasons. They also found light and dark markings that changed their shape and location. In the late 1800s, the Italian astronomer Giovanni Schiaparelli reported that he saw a network of fine dark lines. He called these lines canali, which is Italian for channels. But canali was generally mistranslated as canals. Many other astronomers also reported seeing such features. Among those observers was the American astronomer Percival Lowell, who referred to the features as canals. Lowell speculated that the canals had been built by a Martian civilization. The canals turned out not to exist. In some cases, the observers had misinterpreted dark, blurry regions that they had actually seen. In other cases, there was no relationship between canals and real features. However, the changing dark and light markings were real. Some scientists thought that the changing patterns might result from the growth and death of vegetation. Much later, other scientists suspected correctly that the cause was the Martian winds. Light and dark materials blow to and fro across the surface. Observation by spacecraft. Robotic spacecraft began detailed observation of Mars in the 1960s. The United States launched Mariner 4 to Mars in 1964 and Mariners 6 and 7 in 1969. Each flew by Mars about half a year after its launch. The craft took pictures showing that Mars is a barren world, with craters like those on the Moon. There was no sign of liquid water or life. The spacecraft observed few of the planet's most interesting features because they happened to fly by only heavily cratered regions. In 1971, Mariner 9 went into orbit around Mars. This craft mapped about 80% of Mars. It made the first discoveries of the planet's canyons and volcanoes. It also found what appear to be dry riverbeds. The next major mission to Mars was Viking, launched by the United States in 1975. Viking consisted of 2 orbiters and 2 landers. Its main goal was to search for life. The orbiters scouted out landing sites for the landers, which touched down in July and September 1976. The landers took the first close-up pictures of the Martian surface, and they sampled the soil. They found no strong evidence for life. The next 2 successful probes were Mars Pathfinder, which was a lander, and Mars Global Surveyor, an orbiter. The United States launched both craft in 1996. The main objective of Pathfinder was to demonstrate a new landing system. Inflated air bags cushioned the probe's landing in July 1997. Pathfinder also carried a small roving vehicle called Sojourner. The rover rolled down a ramp to the surface, and then moved from rock to rock. Pathfinder sent spectacular photos back to Earth, and Sojourner analyzed rocks and soil. People throughout the world watched television pictures of Sojourner doing its work. Mars Global Surveyor carried a group of sophisticated scientific instruments. A laser altimeter used laser beams to determine the elevation of the Martian surface. This instrument produced maps of the entire surface that are accurate to within 1 yard or meter of elevation. An infrared spectrometer determined the composition of some of the minerals on the surface. A high-resolution camera revealed a host of new geologic features. These include layered sediments that may have been deposited in liquid water, and small gullies that appear to have been carved by water. In April 2001, the United States launched the Mars Odyssey probe. The probe carried instruments to analyze the chemical composition of the Martian surface and the rocks just below the surface, to determine whether there is water ice on or beneath the surface, and to study the radiation near Mars. In February 2002, the probe found evidence that there is much water ice below the surface. The probe indicated that most of the ice is south of 60 degrees south latitude.